Welcome to our first lesson in the Forces unit of Physics GCSE. Today we will learn about scalar and vector quantities. We will first define scalar quantities and discuss several examples. We will then define vectors and discuss how to represent them visually. Finally, we will highlight the differences between scalars and vectors and touch on the implications of this difference for calculations.
So, what are scalar quantities?
Scalar quantities are those that are completely described by their magnitude alone. They do not include any directional information. One example of a scalar quantity is speed. For instance, when you say a car is moving at 50 miles per hour, you're only talking about how fast it's going, not which direction. Another example of a scalar quantity is distance. If a person walks 5 kilometers, this is a scalar quantity representing how far the person has walked, regardless of the direction. Mass is another example of a scalar quantity. Saying an object has a mass of 2 kilograms is purely a description of how much matter is in the object, without any reference to direction.
Okay, so if a scalar is described only by its magnitude, what is a vector?
Well, vector quantities are those that are described by both magnitude and direction. They provide more detailed information as they not only specify how much, but also which way. Velocity is an example of a vector. When you say a car is moving at 50 miles per hour to the east, you are specifying both the speed and the direction, making it a vector quantity. Displacement is another example of a vector. If a person walks 5 kilometers north, the displacement includes both how far and the direction of the walk. A final example of a vector quantity is force. When a force of 10 newtons is applied to push an object to the right, it specifies both the magnitude of the force and the direction in which it is applied.
Okay, so vectors have both magnitude and direction, but how do we represent that visually?
Well, vectors are typically represented visually by arrows. The length of the arrow corresponds to the magnitude of the vector. Longer arrows represent larger magnitudes. So in this case, vector A represented by the red arrow is larger than vector B, which is represented by the blue arrow. The direction of the arrow indicates the direction of the vector. For example, vector C and vector D are the same length and therefore the same magnitude, but the arrows indicate that they have different directions. Finally, let's recap the distinction between scalars and vectors. It's very important to differentiate between scalar and vector quantities because they behave differently in various physical situations. Scalars, being directionless, are added, subtracted, and averaged just like regular numbers. However, vectors, due to their directional nature, require vector algebra for their addition and subtraction. This means you have to consider both magnitudes and directions while performing calculations. Great work. That's the end of our lesson today. In today's lesson, we delved into the distinction between scalar and vector quantities. We learned that scalar quantities are defined solely by their magnitude, with examples including speed, distance, and mass. In contrast, vector quantities are characterized by both magnitude and direction, with examples like velocity, displacement, and force. We also discussed how vectors are visually represented using arrows, where the length indicates magnitude and the arrow's direction shows the vector's direction. By mastering these concepts, we are better prepared to tackle more complex topics in physics related to motion and forces. Watch the rest of the GCSE Physics course at Sophos Education.